Dr. Murthy, with the release of ChatGPT, neural networks has become something of a buzzword these days. Could you teach us a little bit about neural networks?
So now the very first neural networks are solved that were considered were all linear problems. So essentially, I have um, data that is connected to what I'm predicting in a straight line or a planar way. If it's one dimension, two-dimensional data, it is straight line. If it's three dimensions or more, it's planar, hyperplanar way, right? So those are the kind of problems people were able to solve. Let's say between 1955 to 19 um, even 75, 80, people were able to only solve linear problems using this technology. So to understand this neural network, the biggest benefit that neural network had given is the ability to represent this as a nice graph. So what do I mean? So let's say there are x1, x2, x3. I represent each of the inputs as a uh, node. This is called a node. Each of the input is called a node, right? So what is a node is just a input, x1 and x2, x3. Okay. So this is each of these is fed into one node. Now the way neural network writes or visualizes this problem is, hey, you know what? This x1, x2, x3 actually have to predict y. Whatever they have to predict, you connect it with a line, arrow. Okay, x1, x2, x3 go into a node. The what I'm predicting. This is my y node. This is my y node. Okay, so I'm predicting this. Well, I am missing one thing, which that C in neural network word, it's called the bias. So bias is represented as a separate connection. You can think of the node connecting to it as one, because what I need is just the bias value. As somehow in the neural network world, people don't use B, they use B. So let's stick to that. Now, okay, C and x1, x2, x3 are going into predicting y. Now, the way they represent in neural network the weights or slopes, M1, M2, M3, in the neural network world, they are called weights. They are seen as the connection strength. So this one is M1 and this one is M2 and this one is M3. So now I can think of it as M1, M2, M3. Okay. M1 times X1, M2 times X2, M3 times X3 plus 1 times B becomes this equation, if you think about it. Normally, people don't even call it M1, M2, M3. Let's go with the flow. People actually call this W1, W2, W3. So it's not exactly I mean, it's just what you decide to call it, M1, M2, M3, or W1, W2, W3. But in the neural network world, a regression equation is represented as y is equal to W1x1 plus W2x2 plus W3x3 plus B. Right. So that's how the regression problem is represented in the neural network world. As I said, we are in 1955 time frame. So they were only solving linear problems, and hence there are a bunch of inputs, each one fed into one node, and they all connect to the output with these weights which are equivalent to the slopes. And then there is one hanging connection, which is the bias, which here is the C. So this is a nice way to represent a linear equation. Okay. By the way, this way of this network, this linear problem solver is also called perceptron. Essentially linear regression, what we saw. But they, in the neural network world, as you see, we try to make everything sound wise and cool. We don't call slopes slopes, we call them weights. We don't call input inputs, we call them nodes. And then bias, not a constant, we call it bias B. And then the total system, we call it a perceptron.
Dr. Murthy, I could not help but notice similarities between the perceptron and our model of the brain with its neurons and axons. Is the perceptron based on our understanding of the brain in some way?
In fact, I just want to tell you something. Normally, when I look at neural network literature, people start with, hey, this is how brain is connected, and then, this is a representation. I'm deliberately avoiding that because I want you to see it just as a mathematical tool. Then you will also start appreciating why that is, these models are not necessarily our brains. Okay, why we are not replacing humans, why we are only solving problems, right? So that's why I'm deliberately only taking a mathematical approach here.
Oh, that is reassurance one can never get enough of these days, that AI will not replace us and that the perceptron has got nothing to do with the brain. Thank you so much, Dr. Murthy.